Question is a vessel that is of cylindrical shape of radius 50 centimeters and height 1.2 meters. Radius is 50 centimeters is given, that is 0.5 meters, and height h is 1.2 meters is given. Opened at the top, it holds water to half its depth. What is the approximate speed with which the cylinder is to be rotated about the vertical axis so as to make the apex of the paraboloid just reach the center of the bottom of the vessel? We are rotating it with about the vertical axis, half the water is there, so how much speed it has to be rotated. So we have to find out. We know the relationship is h is equal to omega square r square by 2z. We have to find out omega, that is equal to 2zh by r square whole power 1 by 2. 2 into 9.81 into h is 1.2 meters divided by zero point 0.5 square whole power 1 by 2, that is 9.7 radians per second is the angular velocity. But what we have to find out, with which speed it has to be rotated. So omega we know 2 pi n by 60 is equal to 9.7, n is equal to 93 rpm, rotations per minute. 93 rpm is option A, so option A is correct. Question is two coiled springs having a stiffness K. So two coils are having a stiffness of K. And these two are connected in parallel. So the stiffness coefficient is K1 plus K2. Combined stiffness coefficient K is stiffness of K1 first coil, stiffness of second coil. So here the stiffness is K is given plus K, therefore 2K is the answer. So option B is correct. Question is, out of 150 cubic meters of water supplied into a canal, 80 cubic meters of water could be supplied to the field. 60 cubic meters of water in the root zone, while the water required was stored in the root zone prior to irrigation was 80 cubic meters. So we have to find out the storage efficiency of that particular irrigation. Storage efficiency of that irrigation is given by water stored in the root zone divided by water needed prior to irrigation into 100, that is equal to water stored in the root zone. We know that 6 cubic meters of water is stored in the root zone. So 60 cubic meters divided by water needed prior to the irrigation, while the water required was stored in the root zone prior to irrigation was 80 cubic meters. So 80 into 100, that implies 75%. This much of data that was given to confuse us, so we have to collect the data which is required for our question. So option A is correct. Question is, an activated sludge process, the sludge volume after 30 minutes of settling is given as 0.1 meter cube, and that of suspended solids concentration is given as 100 kg per cubic meter. We have to find out the sludge volume index. Sludge volume index can be calculated by using this equation. Sludge volume index SVI is equal to sludge volume SV by suspended solids SS. This has to be in milliliters per liter and milligrams per liter into 1000 milligrams per gram. So sludge volume is given as 0.1 meter cube, that is equal to 10 to the power of 5 milliliters. spended solids is given as 100 kg per cubic meter, that is equal to 10 to the power of 5 milligrams per liter. Therefore, by substituting these values in the above equation 1, we get sludge volume index is equal to 10 to the power of 5 by 10 to the power of 5 into 1000, that is equal to 1000. So option B is correct. Is the sewage is flowing at 4.5 million liters per day from a primary clarifier to a standard rate trickling filter. The 5-day BOD of a influent is 160 milligrams per liter is given. The volume of adopted organic loading is to be 160 grams per meter cube per day, and hydraulic loading rate is given as 2000 liters per square meters per day. Determine the depth of bed required. We have to determine the depth of bed that is required. So first we will find out total 5-day BOD. 5-day BOD present in the sewage is 160 milligrams per liter, that is 4.5 into 10 to the power of 6, 10 cube, 720,000 grams per day. Okay, volume of filter media required. We will find out the volume of the filter media that is required. Total BOD divided by organic loading, that is equal to total BOD, we know 720,000 divided by 160 organic loading, that gives 4500 cubic meters. So if we find out the surface area of the filter media that is required, then we can divide it with surface area, then we will get the direct depth of the bed that is required. So we will find out the surface area of filter media required is equal to total flow divided by hydraulic loading. Total flow we know 4.5 into 10 to the power of 6 liters per day, 2000 liters per square meter per day, that was given. So 2250 square meters of surface area is required. So the depth of bed required is equal to volume by surface area, S, is equal to 4500 by 2250, that is equal to 2 meters, right? So 2 meters of bed required, depth of bed required. So option A is correct.